Hello friends and welcome to 4.4's notes completion. Congruence and transformation. So this section doesn't give us anything new in the form of the type of transformation, but it shows us what happens when we combine some things. So to illustrate these explorations, I'm going to go to our trusty friendly neighborhood GeoGebra page and go through a couple of these items with you to help you better understand what's happening. All right, so first, let us place a triangle polygon. All right, I'm just going to put a triangle up here somewhere. That looks good. And now, like I said, this exploration deals with reflecting this figure, this pre-image, in a pair of parallel lines. So I'm going to put a line at x equals 2, and then a parallel one at x equals -2. Just totally random examples here. All right, so now watch what happens when we reflect this pre-image along the first line we put, x equals 2, and then reflect that image over the line x equals -2. So the phenomenon that occurs here, my friends, is that to go from the pre-image to the end result, it's actually a translation. A translation is what occurs. Gasp. Yes, indeed. You can see the orientation of the pre-image and the image are the exact same. It just moved. So when you reflect along parallel lines, the result is a translation. Now you can tell how far it moved based on how far apart your parallel lines are. So they're 4 units apart, from 2 to -2. So therefore, the translation is going to be 8 units. You just double it, because the distance is from A to A prime, C to C prime, and B to B prime are all 8 units, from 3 to -5, from 5 to -3, and from 4 to -4. They all move 8 units, doubling the distance between the parallel lines. All right, so that's our first theorem today, is what happens when you reflect on parallel lines, and the result is a translation. All right, so now next we're going to take a look at what happens when you rotate. Oh, I gave it away. When you reflect on intersecting lines. So polygon now. I'm going to put it down here so that we can see what's happening. And let's just go here, here, here. So a triangle with those coordinates. Now let's put a couple lines in that intersect each other. Put a line there. And a line there. So they intersect the point D. So now let's see what happens when we reflect the pre-image across a pair of lines that intersect. So click the image, click the first line, so there's that reflection. And then the second image, ooh, look how cool that is. What happens now? From the pre-image to the image, what has occurred? Well, it's definitely not a translation, because we're not in the same orientation anymore. But what happens actually, guys, is it rotates. Gasp. A rotation is created when you reflect in intersecting lines. So these lines intersect at point D. Now check us out. We're going to be able to figure out the degree of the rotation. And to do that, we've got to measure the angle the two lines create when they intersect. So click on my angle feature. So 71.5. All right. Well, watch how cool this is. A 71.5, if I double that, then where's my rotate around a point? So now I'm going to take this original, the pre-image. Now it's getting rotated around the point of intersection, not the origin, like we did in the past, last section. This is going to be around this point. So now if I just simply take the angle 71.5 and double it, that's about 143 degrees. Boom, and look at that. It places the figure, it rotates it 143 degrees counterclockwise. So it's just a doubling effect of the angle. So those are the two theorems that we're going to be talking about in our notes today, my friends. And you can pause and rewind the video anytime you need to see. That's exploration 1 and 2. All right, the rest of the section just involves with identifying congruent figures. And of course, congruent figures means they're isometries, rigid motions, either a spin, a flip, or a slide. These are all called congruence transformations. You move things around, you don't change the size or shape, you just change the location. So now one of the tasks from this section will be to describe what happens. For instance, in example 2, how do we go from the pre-image to the image? And here's an example of how you could do it. First, reflect in the y-axis, and then follow that by a translation 4 units down. So how do we tell that? Well, you're looking at the original. It's not oriented in the same fashion as the answer. So you know they didn't just slide it. They had to have done something to it. And so now you can use GeoGebra. If you're having trouble visualizing, I would say just graph this on GeoGebra and start messing around. You kind of got a general idea. It's not going to be reflected around some crazy line like y equals -5/3 x plus 7. It's going to be one of the axes, or y equals x or y equals -x. So just mess around with GeoGebra if you're having trouble seeing that it got flipped and slid like that. Now the cool thing about this is there's multiple ways to get from that polygon to that polygon. And that's what the monitoring progress question is about. If you go back to example 2, describe another way to get there. And we could also reflect in the x-axis and then slide it to the left. So there's other ways, there's multiple ways to get from the first figure to the second figure in most cases. All right, pause the video here and see if you can come up with monitoring progress number 3. All right, welcome back. So how did we get there? Maybe, well, hopefully you arrived at something like this. Perhaps reflect in the x-axis and then slide it 5 to the right. Slide to the right. Take it back now, y'all. 3 hop one time. Everybody clap your hands. So slides, flips, turns, that's what we're talking about. Now the rest of the section is just what we talked about on GeoGebra to start the lesson. When you reflect in parallel lines, it's a translation. When you reflect in intersecting lines, it's a rotation. So this is it in book form. When you go from x to 2x, the angle gets doubled for the degree of rotation. All right, and wrapping things up today, how else they could ask you, using the figure, the distance between line K and M is 1.6. So the distance between these two lines is 1.6. On our GeoGebra, it was 4. We had one from 2 to -2. So 1.6 is going to mean, okay, well, describe a single transformation that maps the blue to the green. Well, you're just going to double it, guys. You're going to move it. You're going to translate it 3.2 units. Translation. You could put it in vector form. However you want to describe it to me. Number 5, what's the relationship between P So this segment, P to P prime, with the line K, and you can probably guess they will be perpendicular. That's the beauty of reflections. And then the distance from P to P double prime, of course, is just take your 1.6 and double it to get 3.2. So the distance from, the distance from P to P double prime would just be doubling the distance between the parallel lines. Then in number 7, in the diagram, it's reflected, this first blue image is reflected in K and then M. So how do we get up there? Describe a single transformation. Well, of course, this is going to rotate, so it's a rotation. Whenever you reflect in intersecting lines, it's a rotation. And of course, you gotta take your 80 and double it. So that gives you the degree of rotation that you have. All right, guys, so a short little lesson today. Email me if you have any questions. Peace!